So, this is a continuation of quadratics, and what else do they apply to? Money, money, money. Stuff that, yeah, I told my first class I should have put a little picture here, and every time I read that, I press a picture and it plays that song. Next year. Sorry. All right. But do you remember a couple lessons ago, I believe it was Unit 2, Day 1, we did like linear regressions? And we actually did this problem where we put this into our L1 box, and this went into our L2. And we just sat at it and we calculated a linear regression. And we actually came up with this equation. Okay? This was done a couple of days ago, and we're not going to redo it. We're just going to recall the equation we got without having to redo it at this point. But we should have y equals negative 15,358.93x plus 73,622.50. This is a linear regression that we came up with. All right? But now we're doing quadratic regressions. So how do these tie in? Well, if I take my same table, and currently this is our x, and this is our y. Well, right now my linear regression tells me the number of boxes I'm going to sell for that price. But how do I find out the revenue, aka the profit? How do I find out the profit there? Think of it this way, if you're making...
So right here, it's like y equals mx plus b form. So the y, you plug in however many number of boxes you sell in the x, but you got to start on the graph at 73,000. I mean,
that's the graph of the linear regression. You're absolutely right. That's the graph of the linear regression. But if we put an x value to our linear regression, the y value is going to give us the boxes sold, not how much money we made for the boxes sold. How do we find out the number of boxes, or excuse me, how do we find out the profit we made? Well, yeah, that's exactly it. Is that what you were going to say? Okay. But he's right. We find out, well, how much are we charging per box, and then multiply that times the number of boxes we sell. So, well, not in this equation. Not into our linear regression equation. We need a quadratic regression equation. So, for example, if I work at McDonald's, if I'm the manager of McDonald's, I want to figure out how much money we made selling double cheeseburgers that are $1 each. Well, how do I figure out, Donovan? How do I figure out how much money I made? Well, I take the number of double cheeseburgers I make and I multiply times $1. That's how much they cost each, right? So ultimately, I'm just going to multiply the cost per box here times the units sold. I'm going to literally, if I want to figure out how much money I made when the boxes were $2.60 each, I multiply $2.60 times 33,710. How come? Because I projected to sell 33,710 boxes if they cost $2.60 each. How much money is that? I don't know, I'm multiplying. Each box gets $2.60. So if I sell over 33,710, I multiply 260 times 33,710. If I have 5 hamburgers and I sell them for $2 each, well, I multiply them, that's $10 I make, right? Yeah. If I have 20 hamburgers and I sell them at $2 each, right? So that's how you figure out money, right? So we're doing the same thing here. It's just boxes. Yeah, the world needs boxes. Everything you get from Amazon, eBay, there's money to be made there. So it's really taking in this column, we are just multiplying our x times our y, aren't we? Yeah. X times y. So I'm going to rewrite that. I'm going to say my revenue equals x times, but instead of writing y here, isn't y equal to this whole thing? Yeah. Right? Isn't this the number of boxes? The number of boxes, right? And this is the price per box?
Yeah.
Well, if I multiply them together, I get my revenue. Well, this equation right here for y gives us the number of boxes. When it's a linear regression, it gives us our number of boxes. So I'm going to take this whole linear regression and put it in for y. And watch what happens. I take x, and I multiply it times my linear regression, which represents y. which is the boxes sold. So that is negative 15,358.93x plus 73,622.50. And what do I do? Do I got to distribute that x?
Yeah.
When I distribute that x, it takes my linear regression and turns it into a what?
Quadratic.
Quadratic. X squared is the biggest term now. So it's negative 15,358.93. What comes after that? X squared. Plus 73,622.50 what?
Oh, x.
X. That is now a quadratic equation. That is parabola, right? Is it open up or down?
Down.
It opens down. It's going to look something like that. It does have a maximum. I just threw in parentheses. Yeah, I don't have to. I can call this a function, f of x, if I want. I can say y, but don't forget, if it's a linear regression y, it's the number of boxes. It's the quadratic regression. It is the cost, the profit. All right. So, here's a quadratic regression, all typed up nice and neat. And how do I find the max revenue? You made a comment about it. It has a what? It's opened up. Yeah. If this is a negative a value, that means the parabola is shaped like that, right? Which means it has a what? It has a maximum. It has a max, and the max is made up of a coordinate, isn't it?
Yes.
What is each one of those coordinates going to tell us for the quadratic? Not for the linear. The x will be the same. Yeah, it'll be max revenue, but which, am I looking for the x or the y value in that case?
X.
Well, what does each one tell me? X is the cost per box, and y would be the total cost you make, the total profit you make. Okay? So this will be y for linear. The boxes sold is for the linear, but for quadratic, don't I multiply these two together and my y becomes now the profit I make? It does. So, how do I find the max revenue of the vertex? Absolutely. Absolutely. So there are two ways I can do this. Algebraically and in the calculator. And since we have time today, we will do both.
Yeah.
We will do it algebraically, then we'll check it in the calculator. All right? So, remember, if I want to do this algebraically, I need to find my x first in my vertex. Because it's a coordinate. I have an x and a y, right? I have an x and a y point. I can find my x by using this, which is the axis of symmetry formula, right? AOS. And that's that is the imaginary line that cuts the vertex in half where it's reflected over. And it's also the x value in the vertex. So let's take a look at this. We have x equals negative b. Here's my b value. Here's my a value. I got to negate b, so it's negative 73622.50. Well, I hope one day if you had a business, you're writing that many numbers. That means you're making a lot of money. You don't want to write just $720 in a year. Then you're not making too much. All right, we divide that by 2 times my a value. Don't forget, the negative is included in the a value. So it's times negative 15358.93. Put that in your calculator and give me 3 decimal places, and then we'll round it to 2. You know what I'm talking about?
Yeah.
So my x value is approximately, give me 3 decimal places, just cut it off. In fact, I'll do this here. I'll do this up here with you to see if you get the same thing I get. Okay? Alpha y equals, enter. That's that sounds right. That sounds right. 115.
Why it's not?
358.93. He's hating. He's hating on me.
I got the same.
Yeah. Did you? You should get approximately Okay? This is approximately 2.396. And if we're talking price per box, dollars and cents, I should tell them how many decimal places.
2.
2. So that is approximately 2.40. Selling the box at that cost will maximize your profit. That's the cost per box to maximize your profit. Now, what is that profit? Is that profit going to be 38,320? No, it's not. Some people didn't want to figure out my Y value was. I said, well, now, if this is our X, how do we figure out our Y? We plug it into our equation. And people said, in my earlier class, well, no, we already did that. Here it is. Why were they wrong? How come?
That's the linear regression.
That's the linear. Is that going to give me my profit? What is that number?
The box is sold.
Yeah, I'd have to multiply them together and I can get it. But we are going to use our expression, our equation, and our Y, which is our revenue now, is going to equal negative 15,358.93 times X, which is 240, right?
240
Squared plus 7,362.50 times X, which is 2.40. So approximately, rounded to 2 decimal places. What's our revenue going to be there? Yeah, I would. I mean, unless you could do that in your head, that'd be amazing if you could. Your grade would soar if you could show that you could do that. 0.93 times X was 2.40 squared. All right, plus, you should be doing this in your calculators too. So. Ooh, where did Visca mess up? Did I put a minus instead of a plus? I have to multiply times X times 2.40. Yeah, that's $88,226.56. That is the profit we'll make. Now keep in mind, it's $88,226.56. Your approximate profit. You're selling cardboard. It's a box.
So it's nothing in the box?
No, this is just the packaging. You know what the great thing is? If you make cardboard boxes and you happen to get a customer like Amazon that ships things worldwide every day, I mean, I can't tell you the number of Amazon boxes that come to my house. My wife spends money on that stuff, and I do too. It's not just her. But worldwide, if you had that one account, that'd probably be enough to make you set for life. But then you get all the hospitals that got to ship some stuff, and all companies, like when my father's company made the metal plate for Subway, we had to put them in boxes and send them to the company that put together the microwaves for them. The people in the microwaves had to put them in cardboard. I mean, they're just yeah. In fact, it's also and then no, this is very good because sure, what happens if you make boxes? And you go, okay, this is good, and every time a customer asks you, oh, you got boxes, do you have packing peanuts? And you're like, no. And then another comes, you have packing peanuts? And you're like, no. And then at some point you're going to be like, look up the cost to get packing peanuts. And if they're 10 cents a pound, which they're not. If they're $1 for 100, whatever they are, I'll charge $1.25 for 100. Yeah, those little like peanuts. Yeah. All right, so here's the money, the revenue we came up with. Let's check this in our calculator and use the max function, okay? Let's use that max function. So, if I do this right, we're going to go to y equals, I'm going to turn this bad boy on. We're going to y equals, and I'm actually going to type in our equation. Move this over, we have negative 15,358.93. Now it is x squared now, right? What's that? If we calculated a regression for it, we did not. Remember, we just multiplied the x in for it. But yes, if you're calculating a regression, you can store it with the y variable. All right? So here's my a value, x squared, minus or excuse me, plus, that would have been a big mistake, 73,622.50x. Now, what do you think I should have my window at? Obviously, you see your profit's 88,000. I'm not going to go 10 by 10. It won't show 88,000 in a window.
20,000.
Well, let's look at our x values first. If it's somewhere around 240, I don't know, that should be somewhere around the middle. Let's go 0 to 5. Does that make sense? So my x minimum will go 0, and our x max is 5. How come? Because our maximum point, our vertex, is somewhere in between there. Okay, so let's go from 0 to 5. And we'll go by, I don't know, 1s. It don't matter. Our y, well, money. We never want negative money, so let's start at 0. And our max profit is 88,000, so we probably want to go a little bit higher than that to show. 90 or 100. Either one is okay. 90 or 100,000. Let's go 100,000 to make it even. And we'll go up by 10,000. So we have 10 tick marks on the Y scale. If I would have left that at 1, we'd have 100,000 tick marks on the Y scale. It would be crazy. All right. So now let's graph this. Look at that. Perfect. That is perfect. And you want to be somewhere right at the peak in that, especially if you have a business. Okay? So how do we use the max function again? We make the bow tie. And how do I start that? Second trace is the calc function. And I want to calculate the maximum, which is number 4. And yes, I make the bow tie. The calculator is telling me left bounds. I want to go left of the peak, which is right there. And then I want to go, the calculator now says right bounds. I'm going to go right over here.
I got the maximum.
And you'll see the 2 little arrowheads are pointing to each other. And it's saying, you want me to guess? I hit enter one more time. 2, bam. Look at this. Look at this. Will you look at this? Yeah, what is my maximum? Didn't we have 396 for our x value? 396 for the x value. All right, and that's approximately, if you do it in money, 240. And our y value is $88,226.72. In all actuality, how come ours was slightly off? Ours was off by what? 16 cents? 16 cents we were off by. How come? Because we rounded. We chopped off all this stuff after here, right? And we rounded up. All that extra decimals made a difference of about 16 cents. So when you guys go to the bank and they just drop off, they would have given you $239 in interest. All those extra things matter. They build up. They got thousands and thousands of customers. So they start to make thousands and thousands of dollars over time. And those fractions. It's crazy. Anyways, let's say you were evaluating this for somebody, and you did it paper and pencil, and you came up with this answer right here. And someone said, well, how accurate is that? Within 2 dimes, 20 cents. So someone's going to go, wow, really? Yeah, absolutely. 15 cents. This guy knows his stuff. And then if you calculate 90,000, someone like, how accurate? Give or take 3,000. It's a big gap, $3,000. If you're off $3,000, that might be someone I might do something with that money. But if you're like within 2 dimes, 3 nickels. My figure's accurate within 3 nickels. I don't know. And then when it happens, that's when you're the man. That's when you get the work. All right.